SAS demonstration Proc Tabulate. For this demonstration, we will make use of the dataset blood to show how Proc Tabulate can create different types of tables. This is the same dataset we used for Proc Report, so we're reading in 1,000 observations, and for each observation we're reading in the subject number, gender, blood type, age group, white blood cell count, red blood cell count, and cholesterol. So those are our three continuous variables that will be read in. We are going to start with a very simple table, and then we will build up to more complicated tables as I go through this demonstration. So the simplest table to produce with Proc Tabulate requires a table statement and either a class or a var statement. The class or var statements are used to define your variables as either categorical, which goes in the class statement, or analysis, which goes in the var statement. To use a variable to subgroup results, you list it in a class statement. To use a variable to calculate a statistic, such as a mean or a sum, you would list it in the var statement. So with the data that we're working with, the variables red blood cell count, white blood cell count, and cholesterol would go into our var statement. The variables gender, age group, or blood type would go into the class statement. The table statement is used to define the table. You use it to lay out the rows and columns that make up your table. So in our first simple example, there is only one variable, sex, which goes into the class statement, and then it is listed in the table statement. So let's take a look at our first table that's produced by Proc Tabulate. We only have one variable in the class statement, and we're not changing any of the defaults. So this is the simplest table that you can produce with Proc Tabulate. All it's telling us is the count of females and the count of males in our data set. Now let's say we want to make the table a little more interesting. So here we want to place information about more than one variable. We want to look at both gender and blood type next to each other. And notice here that I've left just a space, sex, space, blood. And so gender and blood will be concatenated next to each other. We're not using a comma or an asterisk like I had talked about with the PowerPoint slides. We're just starting with a space between our two class variables. And notice that the variables in our table statement must be either listed in the class statement or a var statement in order to produce the table. The other thing I've added is a format statement. And I'm saying here that I don't want any digits to the right of the decimal point. And I want the number to be 6 digits wide with no values to the right of the decimal point. So let's see what table 2 looks like. So here you see a demonstration of concatenation. So we have gender and blood type right next to each other. And again, all we have are the counts within each subgroup. Because of our format 6.0, there are no values to the right of the decimal point. In table 3, we are going to make use of the comma. So the comma is used in a table statement to control the dimensions of the table. With no comma, your table information is all presented in columns, as we saw with table 2. When we have a single column, the variables following the comma are your columns. The variables before the comma are the rows. So here we have our two variables, gender and blood type, and we have a comma. So the variable blood type is going to represent our columns. The variable gender is going to represent our rows. So here's what it looks like when we have a comma in our table statement. So here we see the variable gender represents our rows, the variable blood type represents our columns. Again, all we have in each cell is the count. If we added a third variable to our class statement, so let's say we added age group to our class statement, if we have a comma separating age group from gender and then gender from blood, we're going to have a table with dimensions page, row, column, so that age group represents the page, gender still represents row, and blood type represents column. So let's look at table 3, where the dimensions are page, row, and column. So here you have a separate table where age group is young and another table where age group is old. So we've looked at table operators where we have just a space between our class variables, and then we looked at using a comma in our table statement. The last kind of table operator that I want to talk about is the asterisk. So if you specify an asterisk between sex and blood, blood type is going to be nested within gender. So the second variable is nested within the first variable when you use an asterisk. So here we are demonstrating table nesting. And so here you see that within females we have their blood types shown, within males we have their blood type shown. So this is a table with nesting that was produced by using an asterisk in our table statement. So we've looked at several different ways to produce a simple table with Proc Tabulate. Now let's see how we can embellish the tables. We're going to start by inserting an all after gender. And by doing that, SAS adds a row showing the totals of each level of blood type. After blood, SAS inserts a column showing totals of gender across blood type. So we have an all statement both after gender and after blood, so that we'll get totals both for the columns and totals for the row. So here in table 5, using the keyword all, we have summaries for each column and a summary of counts for each row, and showing our total altogether of 1,000 participants that were analyzed. You can add new labels in the Tabulate procedure to customize the report. You can also remove labels altogether if they are not needed. In this example, in the output that follows, an equal sign is used to attach a text string to be used as labels to various items in the table statement. So here, in our table statement, we say sex equals gender. So that's going to be the label that's going to be used for the variable sex, and blood type is going to be the label that's used for the variable blood. And we're keeping the keywords all in, and so that we also have a total column and a total row for our data. So here we see we've just changed our variable labels. The table structure is exactly the same as the previous table 5. The only thing that's different is that we've changed these labels here. So far we haven't looked at all at the var statement and what we can do with our continuous variables. So in table 7 we are going to demonstrate how to use analysis variables. So notice for table 7 we don't have a class statement at all because we're not working with any of the classifying variables. We're just working with the analysis variables. So again, we have to use either a var statement or a class statement with Proc Tabulate, and we're listing these two variables, RBC and WBC, and then we just have a table statement. So let's see what Proc Tabulate does with this. When the var statement is used without any options, by default, SAS produces the sum. And here we have for red blood cell count, the sum of the red blood cell count for each of the 1,000 individuals in our data set. And similarly, we have the sum for white blood cells of all of the 1,000 individuals in the data set. So that's not really very meaningful to us. What would be more meaningful is if we produced the mean red blood cell count and the mean white blood cell count. So to do that, we need to specify our statistics of interest in the table statement. So here we're saying RBC asterisk mean and WBC asterisk mean in our table statement. And so instead of producing the sum, we're now going to see that SAS provides the mean for these variables. And here are the mean levels for the 1,000 participants. Let's say we wanted to specify more descriptive statistics. So here we're interested in not only looking at the mean, but we also want the minimum and the maximum for each of the two variables RBC and WBC. And notice I've also changed the format here. I'm adding a format comma 9.2, which writes the numbers with commas separating every 3 digits, and there are 2 digits to the right of the decimal point. So let's take a look at Table 9, where we're specifying more than one statistic. So here we have for each of the variables RBC and WBC the mean, the minimum, and the maximum. And notice we have this comma 9.2 format for it. Again, I want you to also notice that these two variables are concatenated together, and the reason they're concatenated together is because there's a space between RBC and WBC. What if you want to see the mean red blood cell count and mean white blood cell count broken down by one or more of the class variables? You can combine frequencies and descriptive statistics in a single table. In the code for Table 10, we are requesting the mean RBC, WBC, and cholesterol levels broken down by gender and age group. So for this table, we are going to make use of both the class statement and the var statement. And here in our table statement, first of all, we are going to have age group nested within gender. And then for each of those cells of age group nested within gender, we're requesting the mean red blood cell count, white blood cell count, and cholesterol level. So the variables that are going to be shown are the mean levels for the combination of age group within gender. So we're getting a little more complicated here. So here's what we're seeing. Age group within gender and our mean levels of each of these analysis variables. So for females who are categorized as old, their mean red blood cell count was 5.48. Using the all keywords, we get the mean for females for each of the analysis variables, the mean for males for each of the analysis variables, and the mean for everybody together for each of the analysis variables. Now let's take what we did with Table 10 and customize it a little bit more. So in Table 11, we are going to customize our table. We are going to associate a format with a particular value. For example, 7.2 allows 7 digits, including a decimal point, and 2 digits to the right of the decimal point. So here we are just looking at the analysis variables red blood cell and white blood cell, and we're attaching different formats to each of these variables. And we do this by adding another asterisk and then F, which stands for format. So we have RBC, we want the mean RBC with the format of 7.2. For white blood cell, we want the mean with a format of comma 7 dot. So F stands for format. So here you see that we've specified formats that are different for each of the analysis variables. Now we are going to try to customize our table some more with the key label statement. So this is a totally separate statement that you can use in Proc Tabulate. And so instead of printing out mean, we're going to ask SAS to print out average. Instead of printing out the keyword all, we're going to have it print out the label total. And for STD, we're having it print out standard deviation. Notice for the analysis variables, I'm attaching different formats for the mean and the standard deviation. And for white blood cell, also I'm attaching formats. And I'm using a comma, so we see here tables, gender, comma, red blood cell, and white blood cell. So we are going to see that within gender, we're going to show the mean red blood cell and mean white blood cell within gender. So let's take a look at Table 12. So here, instead of seeing an all, we have the word total. Instead of seeing mean and STD, we see average and standard deviation. And notice then for each of the variables, we have a different format based on the formats that were indicated in the table statement. Now let's say we wanted to eliminate the N column heading. And this can also be done with the key label statement, but I'm going to show you how you can eliminate it within the table statement. So we're going to start with just the simple table of just gender. So we have a class statement for sex, table sex equals gender. In the first table statement, we're going to have this N row included, and in this second table statement, we're going to have the N row eliminated. So to have the N row eliminated, we have an asterisk, N equals a blank, quote, blank, quote. And also notice that again with Proc Tabulate, you can have more than one table statement within the procedure, and both tables will print out. So let's take a look at the two tables that are produced under the heading Table 13. So here is the first table where the N row is left in the table. So you have this row saying N and then giving the count of females and the count of males. In the second table, we don't have that N row at all included in the table. So again, the way we eliminated that was just within our table statement, we had this asterisk, N equals, quote, space, quote. Or we could have done the same thing by having a key label statement with N equals, quote, blank, quote. Either way, it would have produced a table where we eliminated the N row. Now we're going to demonstrate a more complex table. We're going to use this option called No Seps, which removes the internal horizontal separator lines from the table and makes the table shorter. This is the same table as Table 10, but we're also adding formats and labels, so we're trying to make it prettier. And note that we have a null label for sex and age group. This eliminates the rows that displays these variable names. So let's go through this. We're listing in our class statement gender and age group. We're including this No Seps option with the Proc Tabulate procedure. Our analysis variables are red blood cell, white blood cell, and cholesterol. And so here's our table statement. It's getting even longer now. We're showing age group nested within gender, and we're interested in looking at these three analysis variables for those combinations of age group within gender. We're using the key label all to equal total, so we're not going to see all printed in our table. For cholesterol, we have the label cholesterol. For each of these variables, we're interested in the count, which is represented with the statistic N, and the mean, and we're attaching formats for all of them. So let's take a look at Table 14 where we've combined categorical and analysis variables and tried to make the table prettier. So you can see here that with that No Seps option, the table becomes a lot more compact. We have here the count and the mean for age group within gender. And we have our summary means for the older participants in our data set, the younger participants in our data set, and all the participants in the data set. Now sometimes it's helpful not to just look at counts. A lot of times we're also interested in looking at percentages. So in Table 15, we are going to look at counts and percentages. And so to do that, here we're looking at just blood type. In our table statement, we list blood, we're giving it the label blood type, and we're saying that we're interested in the count and the percentage. So percentage is given this name PCTN. So here within each blood type, we have the count and the percentage. Again, this table doesn't look that pretty. So we are going to do some things to make this table look a little more readable. So how can we improve the appearance of output for percentages? To get percent signs with our percentage numbers, a user-defined picture format was created. It allows for values up to 3 digits before the decimal place, with the rightmost digit always printed. The zeros and nines are placeholders. The percent sign in the picture definition prints as is. So this is a very different type of format statement than we've seen before, this picture format. If you are interested in showing the percentage signs with Proc Tabulate, I would just copy this code right into your own SAS code to do this. So here we're just looking at the variable blood type, and we're attaching this new kind of format. So we have percent, PCTN, asterisk, F equals, and this is the format that we want for our percentage. And then we're using the key label to change N to have the label of count and PCTN to have the label percent. So let's run this code and see how table 16 differs from table 15. So notice here the difference. We have count, percent, and notice we now have the percent sign shown with our percentage. For table 17, we are going to have gender for rows and blood type for columns, and we're requesting counts and percentages. The keyword RTS increases the row title space. So we're setting our row title space to be equal to 25. We're again making use of this picture format. So we have our class statement with sex and blood, and because our table statement lists table blood and then comma sex, the rows are blood type and the columns are gender. So let's take a look at what table 17 looks like. So here we have the rows being blood type and the columns being gender, so we have a cross tabulation table, and within each cell we have our count and percentage. But what type of percentage are displayed here? So let's take a look at this. Here we have 178 females with a blood type of A, and it says that the percentage is 17.8. Well, this is not the column percentage within females. What this is from our total 1,000 participants, 178 are women with a blood type of A. So if we were interested in what was the column percentage within females, so what was the distribution of blood type within females, this percent is not the correct percentage. In order to get percentages within columns, like the percentage of blood types within females, we would need to use the col percent to compute column percentages. So table 18 shows exactly what we did in table 17, except we're now using the keyword col percent to get our column percentages. So here we see the appropriate percentages within gender for blood type. So of the 440 women in our data set, 178 or 40.4% had blood type A. The very last table I want to show you is what I call a characteristic table for all patients. So this can be very helpful instead of typing out a patient characteristic table where you have a bunch of categorical variables, usually gender, age group, race, ethnicity. It can be very nice to use Proc Tabulate to produce this. And so I'm going to start by just building a simple characteristic table with just gender and blood type. So each of the class variables are listed in the table statement in the first parentheses separated by spaces. Following the comma, the format of the count N and column percentage are indicated in parentheses. So what SAS does is it produces a table of participants who have complete data on all the class variables. So if you have a data set where you have complete data for all the subjects on all the class variables, then that would be included in the table. If a subject was missing on one of those class variables, then that particular observation would not be included in the table. To include all participants in the table, you would need to include a missing option in the Proc Tabulate statement. But here we have complete data, so we don't need to use the missing option. So basically, in my table statement, I'm listing each of the variables for my what I call patient characteristic table. And after the comma, this is the statistics that I want. I want the count and the column percent, and also with the asterisks, I'm telling what format for each of these variables. And then I'm giving the key labels. N is going to equal count, and col percent is going to equal percent. So this is what I call a building of a patient characteristic table. So we have blood type, gender. If we had other classification variables, then those would be listed similarly to gender and blood type. So you can see that there are many, many tables that you can produce with Proc Tabulate. Again, I recommend that you start simple, meaning get the layout of the table first, and then go ahead and add the formats, the key labels, the specific statistics that you want. But first, make sure that you have the table laid out in the way that you'd like by either using a space between variables in the table statement, or a comma between variables in the table statement, or an asterisk. This concludes the SAS demonstration on Proc Tabulate.